Saxon Algebra 2, lesson 23. You guys, I'm pumped for this lesson because I've been building up to it for quite some time, and today we get to talk about it, and then we're going to move beyond. This has to do with solving systems of equations. We can solve, write this down, I spelled it wrong, systems of equations by, we have different strategies we can use to solve systems of equations. The first one is substitution. You know that, you know how to do it. You plug it in. You need one of the variables to have no numeric coefficient, and then you rearrange and you plug it in and it's all good. The second way that you know is elimination. That's where you look down the columns of the variables and you figure out which one you want to use, and then you make sure that it has the same numeric coefficient with a different sign, plus or minus, and then you squish, right? You add the two lines together and go from there. These are both really good methods. Substitution, you have to have the one variable with no numeric coefficient in order to get it to work. Elimination works with pretty much anything. These we used all the time. This third one is much less effective, and we use it far less often. It's important that you understand that it works, but it's also important that you understand that it's a pain in the neck and we use it rarely. It is to solve a system of equations by graphing. Okay? Theoretically, it's cool. In practice, it's really dumb. So let's try one. How's that for a lead-in? Your math teacher telling you, this is dumb, you guys. Solve this system by graphing. Check the solution by using either substitution or elimination. All right, so we have to do it twice. Thanks, John. Way to be a buddy and a pal. Okay, there's our two equations. Yes, they are weird because they have the y's first and the x's in the middle. Plain numbers over there. There's a method to John's madness. This is A, this is B. Okay, solve it by graphing. Okay, so what that means is that we're going to actually graph those lines. We haven't really done that. We haven't really thought about systems of equations as being graphable, but they are. All we have to do is get them into y equals mx plus b mode, right? That's our savior right there. So that makes these kind of a pain, but that's okay. We can do it. So we're going to take A and we're going to put it into this format. So the first thing I'm going to do is mentally add 2x to the other side. 3y equals 2x plus 6, right? Because that's positive. That becomes positive. And now we need the y by itself. So we're going to get y equals 2/3 x plus 2, right? So there is our y that we're going to graph in just a minute. B, we have to do the same thing, rearrange him. Oh, but that's going to be so much easier, isn't it? Because all we have to do is subtract the x. So we get y equals minus x minus 1. And we have a sign here, but we don't have an actual slope. So I'm just going to put it in. It's 1/1, right? Easy. All right. I'm going to squeeze my graph in onto this page. Now we have these two equations written in graphable mode. And I'm going to just put in a few values here. Right? There's no need to overkill this with details. I'm all for just being practical. You guys are keeping up with me, right? I'm not going too fast, am I? Oh, I hope not. I always go so fast, you guys. I get excited and I just can't help myself. But I don't know that any of you have mentioned it, but a lot of my other students have said, can you go slower? I'm trying. I'm really trying. All right, let's graph them. Y equals 2/3 x plus 2. How do you graph again? Oh yeah, you go to the y-intercept first, positive 2. And then your slope is the rise over the run, or if it's negative, the sink over the run. rise always goes up, run always goes to the right. So we go up 2 and over 3. 1, 2, 1, 2, 3. I think we've done enough graphing review this year. I'm not sure how much we've graphed though. If this is confusing to you, tell me when I video chat with you so that I can give you a better review. If you don't remember how to graph, just let me say it again. Start at the y-intercept, plug it in, then use the slope to go either up and to the right, or if it's a negative slope, down and to the right. This one's a positive slope, so we go up 2 and then over 3 to the right, and there's our line. Now, beautiful, right? There's A. What I'm going to do is, I'll just stay in the same color, it's fine. Now we're going to plot our second line on the same graph. Okay, so this time we go to -1, that's our y-intercept, and then this tells us to go down 1, and the bottom is always to the right, so down 1 and over 1, okay? So we see, oh look, there's the way the other line is going, which means that the point where they intersect, that's the solution to the system of equations. So it appears that they cross, and this is where it gets really messy, you guys, because I didn't draw it that precisely, right? I just eyeballed these, and I'm just doing my best. I'm going to say that they crossed somewhere around -2, 1. Okay? That's my approximation of solving the system by graphing them. That's my best guess. Now you can see, it's wildly imprecise, isn't it? It's just kind of crazy. So now what we're going to do is we're going to check it, as John asked us to, by either substitution or elimination. All right? So I'm going to copy these to the top of the next page and carry on. It's positive 3y minus 2x equals 6. And there's lots of ways that we could do this. This is the system, but I just had a really fun idea. Let's go back to this. I wrote both of these to be y equals, right? So if y equals both of these things, then I could say 2/3 x plus 2 equals minus x minus 1. Do you see what I'm saying? If these are the same, then those must be the same. I want to do it like that. That just seems really fun to me. So what is that? That's a weird kind of substitution, right? So I'm going to say 2/3 x plus 2, 2/3 x plus 2 equals, I think it's minus x minus 1, right? Yes, minus x minus 1. Okay, that's kind of a nutty way to do this, isn't it? All right, so I'm going to solve this. The first thing I'm going to do is multiply every term by 3 to eliminate that denominator. 3, 3, 3. So I'm going to get 2x plus 6 equals minus 3x minus 3. Then I'm going to add 3x to both sides, and I'm going to subtract 6 to swim those that way. I still owe you guys a picture of my teacher, don't I? 5x equals minus 9. So we get x equals minus 9/5. Oh, Lord have mercy. That doesn't look like our answer, but let's just wait before we compare. Let's figure out what our y is. Y equals, we swim that over, we said it was minus x minus 1, right? There's that part of it. So y equals minus 9/5 minus 1. So that's y equals positive 9/5 minus, it's 1, but I'm going to write it as 5/5 because, you know, fraction club. And so y equals 4/5. So there's the answers that we got when we solved it by my cookie substitution game there. Let's copy these answers over to where we put our best guess. And compare them. So this is what we got by graphing. Sorry, I bet I'm out of camera. And this is what we got by, let's call it substitution. I'll put myself back in camera range. There. Okay, and what we see when we compare these two is that we're actually pretty close, aren't we? Because -2, that would be -10/5, and this is -9/5. And this is +1, that would be 5/5, and that's 4/5. So we're super close, but how on earth could we be precise enough to measure fifths on a graph? And this highlights perfectly the limitations of solving by graphing, because our graphs just aren't precise enough to give us the level of detail that we get when we use substitution or elimination. Essentially, it's really hard to see fractions when we graph. All right, so it's fun that you can see that it's possible to take these two equations, graph them, and see where they intersect. It's just hard to get a really precise value on them. But it's good for you to understand that this is how they behave visually. I hope that made sense. All right, I'm gonna turn another page because that one is full. We just have one more example. And it is example 23.2. Solve this system by graphing. Check the solution by using either substitution or elimination. So it's the same as last one. So here's equation A. Y minus 2x equals 2. So this time I'm just going to fix it right away before I even copy B down. I remember I want to get it into y equals mx plus b so that I can graph it easily. So I'm just going to add the 2x. I get y equals 2x plus 2. So there's one graphable equation. And then b is y equals minus 3. Well, that's weird, but that's in good shape, right? Kind of strange. All right. If you have graph paper, like pre-printed graph paper that you want to use for these, it might help your work be a little more precise, right? Because I'm just like eyeballing these. If you're into that, go for it. But if you want to just be like me and do it in your regular paper, just try to be as precise as you can be. All right, let's graph. We start at the y-intercept, positive 2 on the y-axis. Our slope is 2, so it's 2 over 1. So it's up 2 and over 1. There's our second point. And I eyeballed the heck out of that. Not bad. I feel good about it. Y equals minus 3. Now, how do we graph that? I can never remember off the top of my head. Is that horizontal or vertical? I just logic it out. It tells us that no matter what x is, y is always minus 3. So I just go to minus 3 on the y-axis and go, okay, it must be like this. Which tells me our point of intersection, the value of x and y that solve our system of equations is roughly there. It's roughly, let's see, 1, 2, it looks like it's about 2.5 on the x-axis and 3 on the y-axis. So I'm going to call it minus 2.5 minus 3. That's my best approximation of the value by graphing. Okay, now we'll do the same thing. We're going to use substitution or elimination to solve. And then we're going to compare those answers to this answer. I'm going to use my same strategy. If this expression equals y and this expression equals y, then I should be able to say that 2x plus 2 equals minus 3. Make sense? It's the plug-in style of solving, a form of substitution. All right, there's our x. Let's subtract 2 from both sides. 2x equals minus 5. Oh, what am I doing? I'm dividing by x instead of dividing by 2. Oh, that was frightening, wasn't it? That cancels, and we get x equals minus 5 over 2. Oh, you guys, that is the same as minus 2.5, isn't it? Because it's 2.5. So this, we got that doggy right on the nose, didn't we? And then y is really easy to solve for because look, y equals minus 3. It has to be that. So this is by substitution. And this result was much more satisfying, partly because these numbers were simpler. But again, it shows you that this is a fairly imprecise science, and substitution and elimination are the true heroes of the system of equations. Graphing is just like their cool philosophical friend who never does his homework. I don't know what that means. All right, lesson 23 is now complete. And the really great news is that you've now learned a third way to solve a system of equations. Oh, I'm so happy for us all. See you in 24. Goodbye.